You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Thursday, July 2nd, 2026, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santa Maria.
Howdy.
And Jay Novella.
Hey, guys.
How's everyone doing?
Well, it's so freaking hot, Steve. How hot is it? It's like, it was 88 degrees yesterday and humid.
Ew.
It's in the 90s today.
Come to LA. Oh, you're going to.
Kara, it's so nasty. God damn,
it's like you go outside and you can't do anything. You can't work in the sun. My dog is constantly going out and coming back in because when he's inside, it's like, oh, I got to be outside. The moment he gets outside, it's like, it's too hot in here. Out here, he wants to come back inside.
Okay, right now, it's earlier here. It's I'm obviously 3 hours behind you, so we're recording this at like 11 something. It's 71 degrees and cloudy.
Nice.
And I think the high today is 80. That's pretty typical. And then
What's
the low
humidity?
is 60. So 80 to 60. We cool off at night. That's the really helpful thing. The humidity right now is 65%.
So the weird thing that's been happening in the last 2 days is if I'm inside, and my house isn't like exceptionally air conditioned, it just feels regular, like it's probably like 73 degrees or whatever. The second I go out, my glasses get covered in water from condensation.
That's how it was growing up in Texas.
Guys, we haven't had the worst of it yet. The heat dome, we're just outside the heat dome. It's still going to hit us.
Oh, no.
Europe, of course, got hammered, and they're going to get hammered again.
Is that kind of like Thunderdome? Just
the
Raggedy
heat dome?
Man.
It's worse, but it's worse.
So, Steve, when you say the dome, explain. I know we talked about it, but I kind of forget. Like, is it where like the hot air gets parked somehow?
Yeah, it stalls, right? So you have this stalled heat dome that just sort of sits over an area, and the temperature goes way up. Yeah.
Now, can't we just like inject bleach in there and that'll clear it out?
Shine a UV light.
Yeah.
What? So, how long is this supposed to last?
I don't know, a week or two.
So LA will be nice respite for you, and then we get to travel to the land
to the
of winter. Which will be lovely.
I actually don't mind going to the winter in the middle of July.
Me neither.
Okay, so we were having our discussion, Kara, right? Like I sent an email to you guys to let you know that that Iran and Lara, who are the people I'm working with in Australia for the conference, I'm always quizzing them about anything Australian. Like, so what's the weather, guys? Like, give me, what's this winter about? And they're like, Iran's like, I was out in a t-shirt today. It's like, it's not going to be bad there during the day.
Yeah, Sydney's nice. It'll be a lot. I shouldn't say it'll be worse, but it'll be weatherier in New Zealand.
Yeah.
Especially Wellington, I think. Yeah, as we go south. Christchurch, different island completely. But I think because of where Wellington is, there's just more chance of like wind and rain. So it can be kind of crummy when we're like outside. So just make sure we have our raincoats.
Yeah, when you go on a 2-week trip, like a large checked bag can easily not cut it.
Totally, especially when you're going to different climates.
Yeah.
Now, guys, I found out something cool about tomatoes that I actually got a little excited about because I didn't know about this.
What did you discover? What is it, culinary berries, or what's the other way to phrase that? Not
They're botanical fruit and culinary vegetables.
Right.
Yeah. Now, you might think I'm going to tell you that when you plant a tomato, that when you're putting in like the plant, if you buy one, or if you at some point you're supposed to lay it down and put dirt on top of it because it'll make it root more, because a tomato plant will root wherever it's touching soil. That's not it. I found out that you are not supposed to let your tomatoes ripen on the vine.
Hey, you pick them when they're just start to turn.
Right.
Yeah.
And I never knew that. And the thing that really interested me was that what happens is if they're all green, they have not gotten any like sugars from the plant yet. And and they're essentially like, you'd have to cook them like a lot to make them edible. But when they start turning red, when they're like half red and half green, like kind of going over to red, what's happened already is that the plant has shut off giving the tomato anything. It's just connected superficially to the plant at that point. And that's when you're supposed to pick it, because when it starts to ripen, that's when the bugs become interested, or the other animals. So you're supposed to pick it before it goes fully ripe. Like, what you would consider to be like halfway done, it's not there yet.
They also will split on you if you leave them on too long.
Exactly. That's the other thing it said. You're very smart, Steve.
I grow tomatoes, Jay.
Yeah. They said that that weather can actually do them damage when they're in that stage. Because again, they're not being maintained by the plant anymore. Like they're just sitting there on their own. So bring them in. So I thought that was fun.
I had a nature encounter this past weekend. My wife and I were at our cabin on the pond, and the best thing about this pond is there's a family of loon that nest on the pond. And have you guys ever seen a loon in person?
Yes.
I think I've heard them.
They're gorgeous.
I've met lots of
They are
loonies.
these big, gorgeous birds. So we were kayaking on the pond, and at one point we saw the loon. Like we were at the other side of the pond from our cabin. And so we're like, oh, let's see how close he'll let us get to him. And here he was really chill. He let us get close. And then he dove underwater. So we start heading back. And then he surfaces right next to our kayaks and is swimming alongside of us, 5 feet away, 6 feet away, 10 feet away. So we just keep going. And he kept, they dive underwater, they fish, and then they resurface. And they could be underwater for 30 feet, 100 feet, whatever. And 4 or 5 times he resurfaced right next to our kayaks and just swam alongside of us.
Aww.
So we had and then at one point he stretches out his neck and did the loon noise, right next to us.
Nice.
It was
So
awesome.
loud.
It is so, it echoes across the lake. That's why that's every primeval swamp-like setting in the movies.
Yeah.
There's a loon sound, right? That is the sound echoing, even whether they're native to that type of
Can you
region or
imitate
not.
it real quick, Steve?
No, it's really hard to imitate. I could clip one in.
Isn't it like hoo, hoo, hoo?
Yeah.
But it's very loud.
I'll clip it in.
Oh, also for our British listeners,
Yeah.
apparently in the UK they're called divers.
Divers. Okay.
Yeah, they don't call them loons.
They're so pretty. There's so much detail. They're black and white, but the
Red eyes.
feathers are with the red eyes. Feathers are so detailed. Okay, just a quick note before we get on to the regular show. We will be talking about the Evan situation, giving a follow-up. We did get a lot of feedback. We'll discuss that in the email section of the show. Just to let you know, we're still engaged with this. It's not like we're going to forget it ever happened and just move on. But we'll be talking about this a little bit later in the show. But we're going to start today with a back to basics, which I'm really starting to like this new segment of the show. And this one is inspired by an email we got from Fredrik Granlund from Sweden. I'm not going to read the whole email, but he basically says that, he loves the show and he thinks that we often we use foundational terms like skepticism and the scientific method, but we haven't really defined it anytime recently.
Right. So
And
new
he's constantly
listeners are
referring new people to the show, and we're assuming a common language. So again, that's kind of what the back to basics is about. Partly, it's let's go back and and we should do this every now and then, really define what it is that we're doing. So I thought I would do for this episode a back to basics about what is scientific skepticism, which is kind of the prevailing philosophy that we are promoting on the Skeptics Guide to the Universe. Do any of you want to take a crack at sort of a short, pithy definition of what you think scientific skepticism is?
Oh gosh, that's tough.
I think I could do it. I mean, so you're making a distinction between skepticism and scientific skepticism.
Well, because skepticism can be used in a lot of contexts, right?
Yeah.
Which what we mean by skepticism. We are skeptics. We're not like vaccine skeptics or global warming skeptics or whatever. We're scientific skeptics. And that term was coined, by the way, or at least promoted. I don't know if it was actually coined, but it was promoted by Carl Sagan to define his own skepticism, right? Sort of the modern skeptical movement is based upon scientific skepticism. But what do we mean by that?
There's also,
Right.
before you go, Jay, there's also the differentiation between scientific skepticism and skepticism. There's also the differentiation between science and scientific skepticism.
Yeah, and also philosophical skepticism, which is something else entirely.
Okay, so scientific skepticism is a method of thinking where you're evaluating claims or information or using the scientific method. So it's an organized way of thinking in order to get you to a verifiability, or false to be able to falsify something.
That's certainly a component of it, absolutely. So you could frame it in a number of ways. You could frame it as, well, what's the goal? And I think that's what you're talking about. The goal is to only believe things that are true and not believe things that are not true. Or, as T.H. Huxley said, a quote that I like, to portion your belief to the evidence, right? We don't want to believe things just because they feel good or because they're popular or because somebody told it to us or we're trapped in some narrative or there's some secondary gain, right? We want to believe things because it's actual reality and we're constantly questioning what we think to make sure that it's as close as possible.
Yeah.
But how do we do that, right? So that's the goal. I think most people will go, yeah, I want to believe things that's true. Although in practice they don't do that. They state they want to do that, but then they believe lots of things that aren't true.
Would you define it as an epistemology? Like it's a specific way of thinking. It's an attempt at knowledge to differentiate between, I guess, believing something to be true and being able to say, well, we have consensus evidence and it is likely that this is true.
I think so. I mean, to me, the definition relies on the term, half of the term here, scientific skepticism. So it relies on the pillars of science, which means like an evidence-based evaluation and falsifiability. Those are the two critical components, I think, of scientific skepticism. That's how I think
it uses the scientific method.
So absolutely. So there is an epistemological basis to scientific skepticism that we follow. And epistemology is basically the philosophy of how we know what we know, right? It's just how do we know things. And the epistemology of scientific skepticism is, well, there's one reality out there. It actually exists. There is a reality and it is knowable. And the only way to have any kind of reliable actual knowledge about it is what we call methodological naturalism. Some people also take that to the next step, which is philosophical naturalism. And that just means that you follow the methods. That's the philosophical basis of science, that every effect has a cause and there is nothing supernatural or magical out there. So science is methodological naturalism, which means it acts as if there is nothing supernatural. Philosophical naturalism says you believe there actually isn't anything supernatural.
Gotcha.
Does that make sense?
So there is a distinction there. Yeah.
So Steve, you say everything has a cause, but does anyone ever address quantum mechanics and things like superposition in that context?
Yeah, I mean, it all is within the naturalistic philosophy.
Yeah, it does. It does fit in, but it's kind of, sometimes you just can't really give a cause to some of these phenomena that we see. But
I guess the idea here is that
the quantum level, of course.
Right. But I guess the idea here is that there is an explanation and there's the potential for knowledge across everything that exists in the natural world. And if we don't know something yet, it's not because it's fundamentally unknowable. It's because we don't yet have the tools.
But it may not be. Yeah. So it distinguishes between unknowable and currently unknown.
Yes.
Absolutely. And things that are unknowable are just outside the realm of methodological naturalism by definition.
That's what I mean. Yeah. So within that frame, everything is knowable. We
by
just
definition,
may not have the tools yet to know them. Yeah.
What about things that are outside the possibility of human minds understanding them?
So again, it's the shut up and calculate kind of approach of you need to phrase things in a falsifiable way. And if it can't be falsified in theory or in practice, it's simply outside of our knowledge.
Yeah.
Now, if it's only outside of our ability to falsify in practice for now, then that may change in the future. If it's theoretically forever outside of are there other universes that we cannot interact with? Well, by definition, we can't know that, right? That has zero effect on our, if you could state, God made the universe 10 minutes ago to look exactly as if it evolved over 13.4 billion years. It's okay, that is by definition unfalsifiable.
Yeah, so it's no different than something being metaphysical at that point.
Yeah.
Yeah.
Right.
So it's outside of the realm of scientific skepticism.
It's not even wrong, as we say. It's like it can't even be subjected to the scientific methodology.
Right.
So that's kind of the purpose and the philosophy of scientific skepticism. But then there's the what do we do nuts and bolts as a movement? And I think there are three pillars to what we do. The first one is promote a basic level of scientific literacy, right? Understanding all the things that we talked about, having a working knowledge of science so that you can think about, understand, participate in issues that have a scientific basis. Like if you don't have even a basic understanding of how the universe works or how the world works, it's hard to even really think about things, you know? And we encounter this all the time where people say things which are just like gobbledygook. Like, what are you even talking about? Like they're not even getting on first base because they don't even have a basic understanding of like physics and the laws of nature. You know what I mean?
Mm-hmm. Yeah.
The second component is critical thinking. And this is huge. This is so many things, but it's thinking about thinking, metacognition. It's examining all the ways in which our thinking can go wrong. So logical fallacies and heuristics and cognitive biases and all of that, and information theory and misinformation and all the ways in which our brains tackle how we come to beliefs, how we get what is conspiracy thinking, how do narratives affect and ideology affect how we think, motivated reasoning, all of that. And then the third component is media savvy. It's the information ecosystem in which we live. How do we get information? How does it come to us? How do we evaluate it? How do we consume it? So those three areas, I think, are the nuts and bolts of scientific skepticism. You have to have basic level, functional level of scientific literacy. You have to have metacognition where you're thinking about your own thinking, and you have to have some kind of media savvy to be able to evaluate the information that you come to. And with that, again, this is a huge hot topic, obviously. We are constantly trying to more and more closely align what we think is true with actual reality.
Which is why on the show, we do segments where we talk about metacognition and we talk about, tricks and tips and tools, but we also share new interesting science news because that beefs up science literacy. And we also talk about times when journalists or other media approaches get things wrong, or even governments, right? Like just different arbiters of thought that a lot of people follow. We want to call them out when they're doing things that are antithetical to skeptical principles.
Yeah. And the best news items do all of those things at the same time.
Oh, right.
Here's the actual science. Here's how it's being misrepresented, and here's the biases in it and how people are thinking about it.
Steve, what about the distinction between evidence-based and science-based?
Well, that's a pretty wonky thing that is specific to medicine in how I formulate it, but because there is a movement of evidence-based medicine, and you can't apply it to all fields, but this is sort of developed within the context
it's heavy in
of medicine.
Psychology too.
The difference is evidence-based medicine tends to focus too much on just the clinical evidence without taking into consideration the the prior probability or the scientific plausibility. Right? And the problem is you can't do that, right? You just can't do that. You can't do that even statistically or scientifically. You have to consider any evidence in the context of prior plausibility. So that's what science-based medicine. Science-based medicine also takes other things more explicitly into consideration. It's basically what EBM should be. We're like, now you're kind of doing it wrong. This is how you have to do it. And I just wrote an article on science-based medicine about this, how like the death of EBM is what I called it, because like the World Health Organization came out with, we talked about this on the show, their 10-year plan for promoting alternative medicine. And it represents everything wrong with evidence-based medicine, where you could basically call anything evidence-based. It just becomes a marketing term, but they're doing it wrong,
Yeah, because they're not actually looking at whether the evidence is good. They're often just looking at whether something was published.
Yeah, and worse than that, and they always give the game away, and I don't think they even realize they're doing it. They always give the game away by saying the purpose is to find evidence to support these modalities. It's like, no, that's not the purpose. Right. The purpose is to look at the evidence to see whether or not these things work, not to shore up the evidence base for them, but to use evidence to find out what works and what doesn't work. And they never, ever talk about the negative. They never say to find out what doesn't work and stop doing it. Never. Because that's not at all what they're doing. When that's the difference between EBM and SBM, again, the way that it is practiced out there. I know EBM proposes, no, they'll basically define EBM as science-based medicine. Like, fine, you're right, that's what it should be. It's just not that way in practice. And these very specific ways. But that's kind of related to what we do. Like, because that's my area of specialty, science-based medicine. It's applying all of these skeptical tools in a specific area to make sure that we're like really again, very carefully calibrating what we do to reality, knowing if something works or not,
Yeah, so theoretically, those terms should be interchangeable.
They should converge.
But in practice, they're not. Yeah.
But they don't.
Yeah.
But there is a real philosophical underpinning where, like, if you wait, since you bring it up, if you can't even know what a p-value means, right? You can't know what a statistical analysis of how likely it is that a treatment effect works or not based upon the evidence, unless you put it in the context of the prior plausibility. You can't do it. And EBM pretends like you can, right? It pretends like, if you got to a 0.05 p-value, that tells us that it works. Well, not if it's impossible at baseline. It doesn't tell us that.
And the good news is I think more and more stringent journals and statisticians are pushing for, like, you can't just publish a p-value without an effect size. You can't, you need all these different checks and balances in place.
Word's getting out. Absolutely. And it's the statisticians who are doing it because they know this is bullshit. They know it doesn't work.
Yeah.
So where is evidence-based medicine on the spectrum from, say, mostly dead to dead?
Well, I mean, when I say it's dead, what I meant by that was that its purpose is dead, right? It still exists as an institution and as a thing, but its goal was to have the highest standards of evidence dictate medical practice. And what it has turned into is a marketing term that could be used to support anything.
Right.
And the World Health Organization's document is such a classic example of it. It basically proves all of our points. It's like, 'cause, you could support anything you want. You can call it evidence-based. You could pay lip service to gold standard science. It's all meaningless unless you're actually freaking doing it. And that means trying to prove that things do not work, right? Just like that's a core rule of skepticism. Try to prove yourself wrong. We're not trying to prove ourselves right. Science is trying to always prove itself wrong.
Yep. And if you see a scientist that doesn't do that, that's not a good scientist.
Absolutely. Right. So evidence-based medicine has turned into looking for evidence to support what you already believe. Right? Not using evidence to find what does work and does not work, and then not doing what doesn't work.
Steve, I like it when you get emotional about this, like things like this in particular. You're not like yelling out because of politics. You're like, this is scientific skepticism, guys.
Bayesian analysis, Jag. Do you hear me, brother? All right. Kara, tell us about this new synthetic cell.
Ooh, this is a really interesting and exciting development.
Yes,
and again,
it is.
Yeah, it's both incremental and also kind of a new step, which I guess is what incremental means. But I think it opens the door. It's a bottleneck. It got through the bottleneck.
It's a milestone. It's an incremental advance, but a milestone.
But a milestone. It's both at the same time. Okay, so the cell is called Spud cell, and it's a synthetic cell that was produced at the University of Minnesota in the lab of Dr. Kate Adamala. The synthetic biology is not a new field, right? Like, we've talked for years about Craig Venter, who recently died. I think we mentioned that on the show. When was that now? A few months ago? A year ago? Gosh.
Yeah, somewhere in 2025, I think.
Does time exist? Is this like, it's so confusing.
Always a good question.
I know. He died in, April of 2026. So yeah, I knew it was somewhat recent. And so...
April.
Yeah. So we've talked for, years and years and years about the attempts that different laboratories around the world have been making in developing, quote, synthetic life. Sometimes they don't like to use the word life, so they'll say synthetic biology. What exactly does that mean? Well, it can take a lot of different forms, and there have been countless approaches to how to create synthetic life or synthetic biology. Now, if we want to be reductionistic about it and say, like, what is a building block of biology, we could probably go down real small. But if we're talking at sort of the micro level, what do you think is a good place to start? when it comes to biology? What is like a structure that we
cell
could say? Well,
or DNA?
Yeah, the cell
right,
membrane.
a cell. Exactly, a cell. So when we look at a cell, it includes the DNA, Bob. That's very important for biology, but it includes a lot of other things that are really necessary for life to exist. And there have been a lot of approaches, as I mentioned, but two major ways that scientists have gone about this. They've taken top-down approaches and bottom-up approaches. The top-down approaches often involve taking pre-existing living tissue and doing different treatments to the cells to sort of wash out all of the biological material, but to still maintain and utilize what you just mentioned, Steve, the membrane.
That's what Ventnor did, right?
Yeah, that's how Venter's lab first kind of went about it. And other labs have done the same thing. And we think about it when we look at cloning attempts and different attempts at like artificial wombs, very often, or artificial gestation. Very often we're like, well, what do we already have in nature that works? How do we use it and just put the synthetic stuff inside of it, right? It's a good starting point, and it worked well. But what this lab did, which was very, very different, is they said, well, we want to start bottom up. We want to build the whole thing from scratch. And so it's real hard to build the fundamental structure of a cell, especially if you're mimicking a very simple cell that's not, let's say, like a plant or a fungus cell, partially because they have cell membranes, not necessarily the hard structural cell walls. And cell membranes are confusing, right? They're phospholipid bilayers. They have to allow certain things in and keep certain things out and maintain different ionic differentiation on the inside and the outside of the cell. And then not only do they have to exist to sort of maintain the structure of the cell, cells don't just exist in a vacuum. If something is to be alive, or at least, I keep struggling with that life question, or at least to be biology, what does it ultimately need to be able to do?
Well, grow, reproduce,
right.
eat.
It's got to be able to persist. And the only way it's going to persist is to like grow, reproduce, like change in some sort of way. You could probably make something that is quote unquote synthetically alive, but how is it going to be any different than taking life, removing it from any sort of life support, and then watching it slowly die? That's not really synthetic biology. So what these individuals in this new lab did is they started from scratch. They managed to build a cell membrane, which is very, very cool. And then they managed to build the fundamental things that they found to be necessary for the cell to be able to continue and to reproduce. So what do you think cells need to be able to do all of that?
Well, they need, of course, some type of energy source.
Energy source, sure.
So mitochondria, ATP.
Right. So it's like, okay, are they producing their own energy? How are they making all of this stuff? And what are some of the fundamental, think about the simplest cells that exist in the world.
It needs some kind of raw material in addition to energy.
Right.
Mm-hmm, mm-hmm.
And you got to make proteins like ribosomes.
Ribosomes, right? If you look at every cell across all of the history of life, ribosomes are really fundamental. And what do ribosomes do? Why do we need ribosomes?
But they make proteins, right?
Yeah, they do a little more than that, but that is a basic.
Yeah.
That is a basic function of them. So they are considered molecular machines, and they make proteins. They're responsible for protein synthesis across all cells. So they read the messenger RNA and they translate it into amino acids, which then later become proteins. These synthetic cells can do some of that work on their own, but they also need a little bit of help for some of that work as well. So we're not quite 100% there yet. One of the main things that as if I had anything to do with this, that researchers are still working on is that very process. They cannot make their own ribosomes. They carry all the genes that they would need to make ribosomes, but so far, researchers haven't figured out how to get the blueprint material, the genetic code, to actually do the work to make the ribosome. So right now, they have to feed ribosomes to the cells.
Like the enzymes?
Yeah. So they're giving them ribosomes, and the cells are able to utilize those ribosomes, but they're not able to make their own ribosomes. And because of that, it does seem like their ability to reproduce for a long time is cut very, very short. Right now, they're
10
surviving.
generations or something?
Yeah, they're surviving between 5 and 10 generations. And then the ribosomes are just becoming defective. They're breaking down because they're not producing new ones and they're not able to kind of fix the ones that are already there.
Yeah. But what about the DNA anomalies? There's also weird DNA stuff going on here too, right?
Well, and before we even get to the anomalies of the DNA, we should talk about, what the genetic code actually looks like. So how many genes, coding genes, do we have as human beings?
Is it 20? Wait,
Yeah, around
20,000.
20,000 or so? Yeah.
And when we think about a simple cell, like an E. coli cell, right, bacteria, how many genes do you think, and that's like a research model organism, how many genes do you think that they have?
500-600?
4,460.
4,000. Okay.
A lot, yeah.
Nice.
So spud cell, because if you're going to be starting from scratch, you're going to want parsimony, right? You're going to want to make the simplest possible thing. You want it to be elegant. Simplest possible thing.
Minimalist cell.
Yes, absolutely. They made this cell with only 36 genes.
That's nuts.
Yeah. They were like, we just want the basic stuff that we know that we need for the cell to do the stuff we're asking the cell to do.
No ornamentation, just the bare minimum for life, right? That's the goal. That's Venter's goal. That's been their goal, his corporation, for many years. And, they've made progress, but they still haven't cracked that nut.
Yeah. And the thing is, I think it's a loaded question in a lot of ways. How can we know what the bare minimum is for life if we are not yet at a place in our basic research where we know what all of the genes in a very complex cell even do?
Yep.
Back in 2016, one of the scientists in Venter's lab was studying a really kind of simple microbe. It had less than 1,000 genes, and they were able to pare it down to 525 genes. So that was kind of the smallest functional synthetic cell before spud cell. I shouldn't make that claim, but it was one of the smaller synthetic cells before spud cell came on to the scene. And they still couldn't figure out what a third of the genes were doing. They got it down to 525 genes, and they were like, we have 56 of them. We don't know. No matter what we do, we can't figure out what they actually do.
They could be totally superfluous or critical.
Yeah, they don't know. So it's hard when you're going bottom up. This is how you do the work. You go, okay, we add this gene. Does the cell, can it persist? Is this critical for survival? They also developed some really interesting, and I don't want to get too into the weeds on it, but some really interesting physical machining, like structures, in order to feed these cells and in order for these cells to be able to reproduce. Because we have pretty complex structures within our cells that allow different materials. The word fuel feels so almost like elementary, but like different materials to enter into the cell. And we have very intricate structures that allow the cell to build these like microtubule things and like pinch down and divide in a very specific way with the spindles on the end. They wanted to emulate that. They were like, these are two very basic things that cells need to be able to do. And they were able to do it by building these little, what they called feeder liposomes. So they're these smaller lipid containing packets that can fuse to the outside, and then the stuff inside can go to the spud cell. So that's how you get those ribosomes, the different enzymes, the different fuel that they're still having to feed to these cells for them to persist. They don't have waste management either. So obviously, as things break down, they get used. They just build up in the cell, and that seems to be contributing to the cell. I don't want to use the word
things get
death
shitty
either.
fast, I guess.
They do things get shitty fast in bodies. We just have really good systems in place to unshitify them. But if there's no system in place to do that, because it's too simple, it's going to build up and eventually the cell won't be able to keep going. They also use these really interesting proteins. So they added this. The cell didn't make it itself, but they added these proteins that would stick to the outside of the cell, to the membrane, and the weight of it would force the membrane to bend and pinch. And so as that weight continued to push, the membrane would actually bud, and one cell would become two. And that's how they were able to like synthetically induce basic reproduction, which is
that kind of cheating?
No, that's what bacteria do all the time.
Yeah, but it needs help to do that critical thing.
Yeah, well, it needs to help to do everything critical. Like, if that's cheating, so is the fact that it can't make its own ribosomes.
Yeah, they're not there yet.
They're not there yet.
Yeah.
But they're like, these are two, like, if we can get past these things, if we can get to the point where we don't have to give it this stuff, but we can give it the genetic coding to make this stuff on its own, we're there. And that's what they're hoping to get to.
It's funny when I was reading this article that when they first mentioned this, that it needed help, like especially with the ribosomes. I was thinking, wait, are they doing that so that it doesn't go like get loose in the wild and start taking over? But like, no, it's like
no,
it's like
we're
this
not
is
even
the best
close
they could
to there
do.
yet.
Yeah,
exactly. So there's a researcher that they quote in one of the articles. Actually, the article Carl Zimmer wrote for the New York Times. They quote a researcher, Drew Endy, who's a synthetic biologist but was not involved in the project. And he said, I love this, the Wright Flyer flying for 12 seconds doesn't get you a 737. This is just the beginning. Like, this is Wright Brothers era right now, right?
Oh my God, right. But I think, obviously, and this is probably entirely predictable, I think this has an amazing future ahead of it. I mean, any science fiction that doesn't try to at least address this once in a while is going to be missing out, because, man, synthetic life is going to be big, probably, maybe.
Yeah, probably, maybe. I love that. And the researchers agree. And that's why they have formed, this is also very cool, they have formed an organization called Biotic. And their mission is really to have an open sourced community of scientists who are, as they say, it's stewarding foundational advances in bioengineering so that all people can benefit from this, and that across the globe, individuals can be involved in both the ethical conversations around it and the actual science. And so some people argue, like, man, giving everybody access to all of this information is kind of scary, because what about the bad actors? But then the counter argument to that is, well, if there are going to be bad actors, don't you want to have everybody having access to this information so that they can develop the, I don't want to call it the antidote, but the response to that bad action.
Oh yeah,
countermeasures.
That's a reasonable reaction to a lot of disruptive technologies, like nanotech. Even it's like you can't have one bad actor having control of this tech. You need a way to deal with it, using to level the playing ground, essentially.
Absolutely. So the research team from the University of Minnesota, they have published, they're still going through peer review. So the peer-reviewed article that talks about all of this is still not available. But in the meantime, they've published a 190-page tome on their website called A Chemically Defined Synthetic Cell Capable of Growth and Replication, that really goes through every major step, because their hope is we don't want to keep this from people. We want people to learn all of the recipes and do it on their own and see what they can, see how they can improve on this.
Open source, baby.
Yeah.
But then, like, you can imagine a not too distant future where you have like a kit, where you could make these synthetic cells and you can have AI design them with all the parameters, and obviously
it lives its life hallucinating.
And what are the outcomes really here? Like, why? I mean, I guess that's the question that we just sort of assumed in this conversation, but it's an important one to at least point to.
Well, there's a lot of cells, a lot of biology that's critical to industry. Right, the entire cheese industry, for example, or beer, or like, for example, in bread, like yeast is a very simple thing. Also, we now use recombinant DNA and genetically altered bacteria to make a lot of drugs like insulin. Yes. So the pharmaceutical industry is hugely dependent upon this.
How about designing your gut bacteria to do also, because we know how important the bacteria in our body. That's basically such a huge chunk of our body. We're like human/bacteria basically. But imagine being able to build them from scratch with custom-made abilities. I mean, that to me, that's another thing that I think has tremendous potential in the future.
Yeah, I think about the drugs that people have to take on a daily basis to maintain optimal health or to keep a disease at bay. If we could produce a biologic version of that drug, and I know there are biologics on the market, but I mean this in a different way, a synthetic biologic version of that drug that reproduces in the body
Yeah, right.
And that, it continuously forms new versions of itself, but that's so stripped down and so simple, because that's another issue is very often when we're talking about this kind of development and we're using things like you mentioned, Steve, recombinant DNA, living organisms, bacteria, viral vectors, things like that. We either have to manipulate them by stripping them down to their basic parts, or we have to just deal with all of the offshoots, all of the secondary effects of that living organism being involved in the research. If we can build a living organism from scratch and give it only the fundamental things it needs, that helps us kind of make this much more targeted, much more clean.
Mm-hmm.
It's fascinating.
And then, of course, you extrapolate to things like synthetic pets. Maybe we shouldn't go there yet.
Yeah, I'm like, let's not jump to multicellular organisms.
Yeah, right.
We gotta get this one done. Yeah.
Don't tease me.
All right, Jay, do people trust science still?
Well, I'm going to ask you that. Do you guys think that the public has lost their trust in science, or has it lowered going back, say, 20 years?
Oh, man.
That's one of those things. I do follow that kind. I didn't read your most recent article, but I do follow that generally. It's always pretty high, and while it does wax and wane, so it may have taken a little bit of a hit post-COVID, it generally still runs pretty high.
What do you guys think?
Yeah, I agree. I think you're going to say that it's down a little bit, but still generally high. I hope that's what it is.
I also have a feeling that it depends on how you frame the question.
Of
that
course.
The concept of science, institutions, the idea of science and scientists, I think people still see those as like some of the most trustworthy sources. But when you start to talk about the content, I think then all of a sudden the trust number probably goes down.
Yeah, and I'd say like my take on it has been that there has been a big shift in just trusting science in general. Like it is, I think, associated with the decay of trust in institutions and everything. It certainly felt like very politically motivated, that there was a lot of change of mind about science and science institutions because of all that. But this study is really incredible because they shine some light on some of this. And like, for example, like scientists have been accused of being corrupt and, like I said, politically motivated. They're controlled by corporations is another big thing, that perception out there, or unwilling to admit when they're wrong, or scheming behind the scenes. There's just a lot of that going on that you see out in the wild. And also, pretty much every major scientific subject now seems to be a part of some type of culture war, like vaccines at the top, climate change, nutrition has always been, it's been something we've been talking about for a long time, but that's a heavily contested thing. AI now is in the arena, and even public health has entered that arena. So I do think that social media is giving us a distorted picture. It is. I mean, in varying degrees, of course, depending on how far down into some algorithm you are and depending on what site you're on. But the angriest and most distrustful voices, as you guys know, these are the ones that people are hearing because they're yelling the loudest, meaning that they're a lot of people out there that have a lot of this distrust or, believing in conspiracy theories and everything. They're publishing a lot of content on the web, and that has a big factor in what people see. But the question is, is it representative of what people actually think? And that's what they were trying to get to. So what does the survey actually show? What is that? What did he say? Survey says? Remember that?
Survey said.
So there was an international study, had 72,000 people across 68 countries. That's a really sizable study that they did. So the results said that overall trust in scientists was moderately high, which
good.
Makes me very happy to hear, because I was fearing that there was like a huge shift. I didn't have the same takeaway that you did, Steve, and I guess it's partly because I've been polluted by what I'm hearing online. Researchers didn't find any country where the population as a whole had low trust in scientists. And here are some key results. 78% of the people questioned believed scientists were qualified to conduct important research. 75% agreed that scientific methods are the best way to determine whether something is true or false. 83% wanted scientists to communicate with the public, and most respondents also supported scientists participating in policymaking, which is great. I'm so happy that these are the results that came out of this. Some basic takeaways were the public has not broadly rejected science, and the claims of a total collapse in trust have been very exaggerated and have been, we've been pummeled with it, but it's not true. Now, let me go into some more specifics here. So in Britain, the British survey found that 84% had at least some trust in science. Only 2% said that they had no trust in science. In the United States, 77% said that they had a great deal or a fair amount of confidence in scientists, particularly to act in public interest. And scientists are still trusted more than many other public institutions. Wow. Surprising. I don't know. I'm curious to know what our listeners, what their experience is and how surprised they are at hearing these statistics.
It's not surprising in that that's always the surprising result of these surveys, that it's higher than you think. That's why I'm just predicting it's going to be the same as it's been the last 20 years I've looked at these kinds of surveys. But Kara is right. As soon as you drill below the surface, because people support science in the abstract or maybe like the institution of science or the idea of science, but as soon as you get to a specific issue, do you trust them on global warming? Then you start to see the erosion or on vaccines.
Totally. The survey covers some of this, Steve.
Yeah.
So here are some warning signs that they also identified. One of them was in Britain, the percentage of people saying that they trusted science, a lot, dropped from 63% in 2020 down to 34% in a more recent survey. The U.S., like for example, confidence in scientists declined after early stages of COVID-19. Trust also became more politically polarized. The actual story is not now that trust has dramatically decreased. The data is showing that trust has become softer, that it's becoming more conditional. It is becoming more politically divided, and trust may have less influence on what people actually believe or what they do. So here, now getting right to what Kara was saying. So people say that they trust science in general while rejecting the scientific consensus on particular subjects. Like, for example, someone might trust their personal physician but have a general distrust for public health agencies. Or someone might support scientific research but, for whatever their reasons, they reject very specifically climate science. Or same situation, but they might reject vaccine health, where they might accept general medicine, but vaccines are something that they're not believing the consensus. And then again, this covers all the topics that I listed, nutrition and everything. People could trust certain scientists and certain institutions or certain subjects, but then everything else could fall into the gray zone for them. And here's the other thing that I found troubling. Of course, they were saying that people are increasingly encountering scientific claims through friends, podcasts, influencers, social media posts, video platforms, of course, artificial intelligence systems. That's a big one. To answer the question, why is science struggling online? Why? Because real science is typically slow, it's very cautious, it's complicated, it's filled with a lot of uncertainty and a lot of qualifications and a lot of time to pedestrian readers that we don't fully understand it, and a lot of people can't wrap their head around or don't put the time in to fully understand just how complicated and slow these processes are. And then Steve, you say all the time, oh man, that's a 20-year cycle. That by the time we're at the very beginning of a 20-year thing where we might get a medication on the other end of this. Misinformation is crazy fast. It's simple. It comes off highly confident. Is typically emotionally charged. And these things work because we are emotional beings. And it's, this is why, when Steve asked to throw some definitions around on scientific skepticism, it's not a sexy thing. And, it is to maybe a lot of us who are in the weeds here, and we love it and we really appreciate it because most of us were probably born with a little bit of a skeptical backbone. But for a lot of people, it's not digestible, and all of these emotionally charged things that they're seeing online can easily be absorbed because they're appealing to people's fears and things like that. So they're effective. That's communication style is very, very effective.
Yeah, I was just having a conversation with a friend the other day about this and brought up the fact that the it always seems like the bad guys have the best slogans.
Yeah.
Yeah.
You know what I mean?
They have the best clothes too, Steve.
I know they always have the best fashion, but I mean, like lots of things which I completely disagree with. But like too many too soon, it's like, okay, it's a bumper sticker, it's a slogan. People could wrap their head around it. It sounds kind of commonsensically right. It's complete bullshit. But then if it takes you 10 minutes to explain why a pithy phrase is wrong, you've kind of lost the PR war. Right? There's a fundamental asymmetry here where it takes a lot less time to create a misconception than it does to correct it.
Yeah.
And so we're constantly working at a disadvantage, trying to sell a nuanced, complicated, thoughtful opinion about something versus something that's optimized to be a good slogan. Right? That asymmetry is just so frustrating.
Yeah, and I think overall, we don't have the number of science communicators out there that we should, I think, as far as like the very, very charismatic, right? We need, there's a lot of good people out there. I mean, I don't want to be misinterpreted here, but I'm talking more not about the quality, but about the reach. How many really, really famous science communicators are there? And I don't, you can't just snap your fingers and make one. Like there has to be a very charismatic and very intelligent person to become a future world famous science communicator. But there's
it's not just that. I think there's probably a lot more than you think. It's just hard to peek through the top of in the terms of the media.
Yeah, for sure.
Right? It's like, are there really more like incredible guitar players out there than there are knowledgeable scientists who will enthusiastically talk about their science? I'm not convinced of that. It's just a lot easier to get media attention, if you're one than the other. So I would love to live in a society where we were silly with science communicators. They were all over the place.
God,
you know what
right?
I mean?
So, Kara, that's why I've been thinking, you need to step up.
Doing what I can, Jay. Doing what I can.
Yeah, you're such a slacker, Kara.
Maybe we need to come up with like a catchphrase like Dr. Kara, something like that. We need something like
That's
that.
what my
that was
patients
great,
call me.
Jay.
Yeah.
How'd you come up with that?
That's what my patients call me because Dr. Santa Maria is like such a mouthful.
Dr. Kara.
Well, we need something pithy and fun. We got to work on Kara.
All right. Thanks, Jay. So, guys, what do you know about geothermal energy?
I know everything about it.
All right. Tell me.
Well, there's hot stuff, and you can get energy from it, Steve. It's pretty awesome.
Yes.
It's
Well,
all
there's
about the
ways-
temperature gradient.
Yeah, and there's ways to do it artificially with like burying like tubes and stuff. And then there's also ways like Iceland's most of their infrastructure is geothermal, but they have a lot of natural geothermal energy under the ground.
Yeah, so you're confusing two things there, Kara. So like the burying the tubes underground. I think it sounds like you're talking about like a geothermal heating system for a house. I'm talking about generating electricity.
Oh, just generating the electricity. Okay.
Geothermal electricity.
And is that from natural sources of geothermal energy?
It's always from natural sources by definition.
Yeah.
Yeah.
It's geothermal.
So it depends on where you are in the world, whether you can tap into it, right?
And
Yeah, so you guys know like the basic physics of how it works. Like what
it ultimately relies on radioactive decay.
that may be the ultimate source of some of the heat.
So, Steve, are you saying you like harnessing energy from vents?
How do
That type of thing?
geothermal plants make electricity? What do they do?
Okay. So it's not how does the heat exist under the ground. It's how do they take that and
Yeah,
make
how
it
do you
Take the
make electricity
heat,
from-
boil water, get steam, and from there, that's when you got steam. You got electricity essentially.
You turn a turbine and it makes electricity. How do they get the heat?
Yeah. So what happens is, Steve, you would pipe down cooler water that goes down into the ground. It gets heated up. When it comes back in, you could harvest the energy off of that, and it just goes through a continuous cycle of pulling the heat up and out and using it to generate electricity.
Totally wrong, Jay. It's all about earthbenders.
So is it about the differential between the hot and the cold?
Yeah, the gradient.
It's just a way of heating
the
water.
temperature gradient.
Right? It's really the gradient itself it's the absolute temperature that's important. Not the gradient. Where we talk about gradients is like how deep do you have to go to get to the temperature you want to get to in order to generate the electricity.
Which is why in places like Iceland, where it's all volcanic, like right under the surface, they don't have to dig that deep.
Are you saying the gradient's not important?
Well, it's the absolute temperature you get the water up to.
I mean, if
right?
everything was the same temperature, man, you ain't
Of
getting
course.
any electricity.
All right.
So gradient.
But it's not.
critical.
It's but you're that is.
I understand. There's a nuance.
Yeah, but when you say that, it's not like you're generating electricity from the gradient in the temperature.
It's a prerequisite.
You are heating the water
Yes.
to the point where it boils. The steam turns a turbine, and that makes electricity. But it's more complicated than that. There's a few pieces here. So. And the reason why I'm talking about this, by the way, is because geothermal has been in the news a lot. There's the recent Geothermal Research and Development Act, which was passed, but with bipartisan support.
What?
Kara, you
Wait.
mentioned this
Skeptical.
not that long ago.
Yeah, the Trump admin. This is like one of the few renewable sources that
Yeah.
they're
So
pro.
why is that? Do you think? Why? Anyway, we'll get to that.
Money?
Oh, God.
Is that a good guess?
The simplest geothermal power plant is what it does. You basically drill down to a depth because as you go deeper underground, the temperature gets hotter, right?
Yep.
And when we talk
No way
about
around that.
temperature gradients, it's like how hotter does it get per depth? The average gradient in North America, for example, is 25 to 30 degrees Celsius per kilometer. But that's the average. But in a
less than
young
I would've
volcanic region like California or Iceland, it could be as much as 50 to 100 degrees Celsius per kilometer. And on the East Coast where we are, it's 15 to 25 C per kilometer. So do you have to go down 2 kilometers or do you have to go down 10 kilometers? Or do you have to go down 20 kilometers, right? That's how far do you have to drill to get to Earth that's hot enough to generate electricity with
Make
geothermal.
it worth it, yeah.
It depends on
Right.
what kind of geothermal you're doing. So the easiest type is when you have a hot spring, right? Like again in Iceland, the water's already there. You're just tapping into a hot spring. You pump up the steam basically, and that turns your turbines. But far and away, the most common geothermal is what we call a dry well geothermal because you're not tapping. You have to put the water down there yourself. So then you have to drill 2 different types of wells. A production well, which brings up the hot water, and an injection well, which sends down cool water. And that's, Jay, where you get to this closed loop system. You're sending water down, it gets heated up at depth, then you pump up the hot water, and you use that to generate steam. But there's 2 different ways you could generate steam from bringing up the hot water. One way is you essentially pump that water up under pressure. So now you have water that's at greater than 100 degrees Celsius, which is the boiling point, right? So let's say you're at greater than 150 degrees Celsius. This is the most common type of geothermal. Typically operates greater than 150 degrees Celsius. This is called the flash steam system, where you bring up this superheated water, and then when you release the pressure, it flashes into steam, and then that steam turns a turbine. And
Nice.
then some of that condenses back down, or the water that doesn't turn to steam, you pump back down as cooler water so it gets reheated, and then you just keep going around. Does that make sense?
Totally.
Pump it up under pressure, you'd flash steams, that's where you get your steam. At lower temperatures, you can use a binary cycle where the water isn't turning into steam, it's heating up another fluid which has a lower boiling point,
Ooh.
and that steam drives the turbine. The advantage of those is that they could operate from 70 to 100 degrees Celsius, but typically they're operating between 1 and 150. Right, so you have your low temperature, say 70 to 150, where you have to use this binary system. You have the flash steam system, which operates at greater than 150 C. And then you have supercritical systems, which operate at greater than 374 degrees Celsius. These supercritical systems basically they superheat the water under pressure until you get it into this supercritical phase where it's like a hybrid of gas and fluid. And so it behaves differently. And essentially, with a supercritical system operating at greater than 374, you can get 4 to 5 times the amount of electricity with the same drilling, right? With the same
Wow, that's
setup
the gold
otherwise.
standard, man.
Yes, but that's for the future, right? Right now, we're mainly operating in this typical flash steam system between 150 and 250, like around there. And there's a sweet spot. Obviously, the hotter it is, the more electricity you're going to be able to generate, but the more it costs to drill. And so, there is this sort of sweet spot of between 150 and 250 where it's economically optimal, right? You don't drill any deeper than you have to, but you're at a comfortable temperature for using the flash steam method.
So supercritical, Steve, then is not optimal economically?
Well, the problem it is if you can drill down deep enough to get to those temperatures.
Okay.
Mm-hmm.
Now, again, if you go back to the temperature gradients I talked about, even with a young volcanic sort of hot zone, if you're getting 100 C per kilometer, you're still drilling down 4 kilometers, right? That's deep. That's a deep well to drill. But if you could do it, then it's worth it. You're never going to get there in Connecticut, right? Because we have
Right.
crappy temperature gradient.
Right.
All right. So how much of the world's energy do you think is geothermal right now,
5%.
2%.
Bob?
Price is Right rule. Say 6. Say 6.
5%.
0.3%.
I win.
Which is basically a write-off error, right? It's negligible.
It's just Iceland.
Yeah, basically, it's the places that you would think. In the United States, it's 0.4%, so not much different. So what 2 states make up 93% of our geothermal? What are they?
California
Yep.
and
Alaska.
Oregon.
And Nevada. California and Nevada, because
okay.
they have young volcanic geology, with the rest coming from Utah, Hawaii, Oregon, Idaho, and New Mexico.
Hawaii. Oh, but that's older volcanic.
Yeah, but still, that's relatively better, right? But that's it. So
Yeah.
basically all of it's coming from California and Nevada with a little bit more from those other states I mentioned. That's all about geology, right?
Mm-hmm.
And this is basically where we're going to be unless we can get cheaper, deeper drilling. So that's what all the talk about geothermal now is. It's all about the drilling.
And for context here, the deepest well is 7 kilometers ever. 7. That's it. 7. I mean,
Isn't this why we should be moving away from just having one large connected grid and just having smaller regional grids that are tied to whatever is locally the cheapest type of energy?
Yeah, I mean, I'm not sure that makes that much of a difference. You can still produce what the optimal energy locally.
Yeah, that's true. We can still, if we have excess, we can still, send it away.
Bigger grids are actually better because you could then balance out energy production.
That's true, because we saw what happened in Texas.
Texas is a problem because it wants to be all by itself.
Yeah.
So how are we going to get beyond this 0.3%, 0.4% if we're already sort of picking the low-hanging fruit by building geothermal where we can? And again, it's about drilling deeper.
Drilling deeper and also maybe doing more where we already do it.
How about seafloor drilling?
I don't know. I don't know if that's going to be economically practical to put a geothermal plant at the bottom of the ocean. And Kara, remember I said why is geothermal so bipartisan? And
money.
Yeah, but I threw out why that is. It's because. Now, I'm going to get a little political here, but I'm just reflecting the consensus of opinion that I'm reading, right? This is not my opinion. This is sort of conventional wisdom out there. The Republicans are pretty much favorable to the fossil fuel industry, right? How does the fossil fuel industry get their fossil fuel?
Geothermal.
No.
No, from drilling.
From drilling. Yeah. They're already drilling. So they don't care if they drill a hole and pump out oil or drill a hole and pump out geothermal energy. It's all about the money, right? So
it's not like fossil fuel companies are ideologically tied to fossil fuels.
No, they're tied to money.
Yeah, they're tied to money, which is why they all have alternative fuel portions of their business.
But they are happy to shift over to geothermal because they already have the drilling infrastructure.
Interesting.
They're drilling holes and pulling out money, right? They don't care what form it's in. It's just a matter of the
but there's not enough sites for them to do it.
So they're tickled pink to expand geothermal. Because that's them, right? They're the drillers. All right, so we're basically though stuck where we are. Yes, we could expand within existing sort of low-hanging fruit areas, but there's going to be an inherent limit to that, and it's going to be hard to get beyond a few percentage points, of geothermal with existing drilling technology. And that's, again, not enough. It's not going to be enough to really move the needle significantly in terms of decarbonizing our electrical infrastructure.
So we need new tech.
Yeah. So that's kind of the news item too, is what new drilling tech is there on the horizon? Because if we could, let's say we could economically drill to 20 kilometers, let's say, then you could build geothermal plants freaking everywhere, right? You could put them almost anywhere. And the number of geothermal plants that can get to supercritical temperatures goes up also.
Oh, yeah.
So you have more supercritical plants operating at greater than 374. You have more of the hotter geothermal plants operating between 150 and 250. You could put them anywhere, but it's got to be economical to drill.
Plus, if we ever want to reach a Kardashev level 1 civilization, we got to do this.
Absolutely. So how much geothermal energy is there within, you always have to say within a certain amount of miles, say within 10 miles of the crust?
4.
How much geothermal energy is there in terms of how many years could it run our current civilization?
Oh, wow. Within 10 miles?
Did you say 10 miles, Steve?
I'd say that there's enough energy there that could be
millennia, dude.
It could be infinite. As long as the Earth is there, as long as there's
millions of years. It's millions. Basically limitless. So we are sitting on top of limitless energy. We just need to drill down to it, right?
Yeah, I could see that. I mean, again, what I know about this, I know from having spent some time in Iceland. That country is like 100% renewable. I don't think they're 100% geothermal, but it's mostly geothermal.
Yeah, geothermal is considered renewable.
Yeah, and they're just, existing.
Yeah.
Like it's just going to keep on going. And what I love, this is so cool. It's like the simple version of geothermal. A lot of the houses in Iceland, their hot water taps just go straight into the ground.
Yeah, right.
It's just hot water from there. So you can't drink it. Like you have to boil it if you want to drink it.
Yeah.
But it's like you fill up a hot bath. You're literally just getting your bath water's coming from underneath your house.
The hot spring. Yeah.
That's so cool.
Yeah, man.
Because the whole island is a hot spring.
Yeah.
That's a great apocalypse power source.
I know. I was like, I'm definitely coming here during the apocalypse.
So what are the challenges of the drilling? Let's talk about that. So the deeper you go, the hotter it gets.
And the softer the ground becomes.
No, the harder the ground because it's under more pressure.
More pressure, but it is gooey though. It's ultimately a gooey.
Well, you have to get really deep.
I think you got to get really deep for that.
We're not going anywhere near the gooey part. We're just so it gets harder and hotter, and so the hotter destroys equipment, right? Destroys electronics.
Right.
So we need better alloys that could tolerate the hotter temperatures. You wear out the drill bits. What happens when you wear out a drill bit? You're 2 kilometers down. Your drill bit goes out. You have to pull it up and replace it and put it back down. So it massively slows down the whole process. It costs a ton of money. So harder drill bits that could survive longer would also and make drilling deeper more economical. But there's a company working on a new technology.
Particle beams?
Close. It's using energy rather than physically drilling the...
What kind of energy? This is the way to go, man.
Totally.
I think I read about this.
Like when you say energy beam, like what are you talking about?
Use a gyrotron, which is similar to what you have in your microwave oven, to generate powerful millimeter wavelength electromagnetic waves, right? And these could be directed down metal pipes and then focused on the rock in order to vaporize them. They could vaporize rock with this powerful millimeter wavelength EMF. And then not only that, there's nothing physical touching the rock, so nothing wears out.
Yeah,
and debris removal, you still have to remove the vapor. It's not right. It's not like on Star Trek where you vanish into nothingness. You have to remove the vapor, but you could pump it out with gas, right? It's not rock. You're not pulling out rock debris. You're pulling out vapor debris. So
it sounds so dangerous.
I'm sure you don't want to get anywhere near this thing, but it will be.
But I think deep drilling is dangerous anyway.
Yeah, I don't know if you get too deep. You drill too greedily and too deep, Kara, and that's where the demons are.
The Balrogs are there.
The Balrogs.
But aren't there all sorts of like horrific toxic gases that are released when you drill?
But we could deal with that.
Okay.
I don't know how much of an issue that is. And especially, this is where geologists come in. They know where to dig, where to drill. But There's a company called Quaise, Quaise, who has a working prototype. They plan on completing a 1 kilometer test well in 2027, then a multi-kilometer test well in 2029. And if everything works out well, that big if, right? If everything is sunshine and rainbows, then they plan on having their first working geothermal plant drilled with their technique by the mid-2030s. And again, if all that works out, we may have widespread use happening in the mid-2040s. So that's if everything goes well, and which has never happened in my life, that when we sort of map out a technology over 10, 20 years, that the optimistic timeline is what happens. Maybe with one exception. And what's the exception?
Solar.
No, I don't think solar has exceeded.
I know it's a computer mediated brain interface. CRISPR.
Yeah.
CRISPR is the only thing that's really exceeded, if anything, expectations. Mm-hmm. But other than that, you always say, in 20 years this will be happening. It's 30 or 40 years. You know what I mean?
How do they power such a millimeter wave energy beam? I mean, it's like, do they need like a nuclear reactor?
I was going to say geothermal power, perhaps.
Yeah, that's obviously a good question. Obviously, if you use clean energy to power the process, it's better than burning fossil fuel to
fission reactor, man.
So long as it takes less energy to run the thing than it does to,
Yeah, it takes less energy to build it than you get out of it.
Then it doesn't matter.
It's a net positive. Win. It does matter because we want to minimize our CO2, and the number of years it takes of operation to get to your payback time. You want to keep that as short as possible.
Right.
But
you
wait,
don't want
where's
it to
the
take
CO2?
20 years to get your payback time for either money or CO2 or whatever it is you're doing.
Where's the CO2 in this?
Well, just like we're trying to prevent CO2 release by burning fossil fuel, but there's
that's what I'm saying.
But there's CO2 released in the process of drilling the well. You just want to keep that to a minimum so that your payback time is shorter.
You're right.
Right.
I didn't realize that does it release a lot of CO2?
Well, it's a lot of energy, as Bob was saying. If you're burning fossil fuel to power your drill.
Well, yeah, but that's a big if. If what I'm saying is that it's a closed system so long as it literally takes 1% less energy to fuel the thing than it does to take the energy out.
Yeah, we're talking more about building it, not fueling it, right?
Right, but if you use green energy to do all of that.
Yeah, of course.
And in the end, what I'm saying is so long as it just makes a little more than it takes,
it's a net positive. But almost always when you read evaluations of the technology, they say, what if we build this all with renewable electricity? Here's your payback time. What if we build this using the current mix on the U.S. grid? Which is whatever. It's still like 40, 50%.
And that's the real payback. Yeah.
This is your payback time. What if we just burn natural gas? This is your payback time. Or what if we build a nuclear power plant and then use that to build up 10 geothermal plants, whatever. So there's different scenarios. We like it to be all renewable, but it's probably best to assume the current mix of electricity production in the country.
Yeah.
And ultimately, wouldn't you rather just it's already bad. Wouldn't you rather just burn it now, knowing that then that many years down the road, it'll be 100% renewable?
Sure, but
it's all going to be is it all? I guess is it all going to come out in the wash? That's the question. If it takes more upfront, but the investment
it's a good investment, but it's still better to minimize the upfront CO2.
Sure, yeah, if we can.
But frustratingly, every time I read about these big projects that are going to revolutionize our energy grid, it's always a multi-decadal project, right? Oh, if we're going to increase our nuclear, it's going to take 20 years. Oh, if we're going to build pumped hydro, it's going to take 20, 30 years. Oh, if we're going to do widespread geothermal, it's going to take 20, 30 years. So that's where we are. Every option on the table. Even if we just want to update our grid, it's going to take 20 years. But we need more copper and lithium, but developing those mines is going to take 20 years. Everything we need to do is going to take 20 years or whatever, something like multiple decades. So that's why we kind of have to do everything now, in my opinion, because we can't look back in 20 years and go, oh, we should have done this.
I guess that was kind of the argument I was making is no matter what the mix is now, it's still better to just do it. Yeah.
Okay. So that's your update on geothermal. We need this new millimeter wavelength drilling technology. So hopefully that'll work out. All right, Bob, tell us about solar corona heating.
Yes, sir. So this is a major mystery about the sun. Seems a little bit less mysterious now, potentially. The sun's outer wispy corona is hotter than its surface. And now we may know...
A lot hotter, right?
A lot hotter.
Million degrees.
And we may know now at least partially why, and that reason could be dust. Just dust. So let's talk about this. This is from a researcher at the University of Alabama in Huntsville. He published a study in the Astrophysical Journal. The title is Parker Solar Probe Observations of Dust Mass and Charge Densities and Their Impact on Kinetic ... Just a lot of technobabble there. So let's go into the details of what this title is actually talking about. The lead author is Syed Ayaz. Okay, so let's talk about this a bit. So the corona. What's the corona? This is obviously the linchpin for this entire study. The corona is the outermost layer of our sun's atmosphere, right? It's the wispy plasma that I know we've all seen, all of us hearing me right at this moment, right? We've seen it because we saw totality. We saw, in Dallas, you see the corona when the sun is blocked either by the moon or using, some sort of technology to block the sun. You could see this wispy, glowy plasma around beyond the disk, and it extends millions of kilometers into space. So this is big. So here's the mystery that Steve alluded to here. The surface of the sun, or the photosphere, is about, this is where basically the visible light comes from. It's being emitted from there, essentially. That surface, the photosphere, is 5,500 degrees Celsius, 9,900 degrees Fahrenheit. The corona is 1 to 3 million degrees Celsius or more. It's far, far hotter. So how does that even work? But remember, when you think of this, you got to remember the corona is very rarefied, right? The particles, there's far fewer particles per unit volume, but they're moving a lot faster. And that's what temperature ultimately is, right? Temperature is the average energy per particle. It's not the total heat. So you got to keep that in mind when you're thinking of this disparity between these temperatures. So in this study, in the context of the study, dust in our solar system and near the sun, it's not house dust. When everyone uses the word dust, this is, of course, obviously not the same thing. What I'm talking about here is zodiacal dust. This is tiny interplanetary debris from, say, comets and asteroids. It's composed of lots of different things: silicate minerals, carbon-rich material, metal grains, sulfides, so lots of different components. That's the dust that you will find throughout our entire solar system. Now, the previous research on trying to deal with this mystery focused on a few things. When they were trying to study why the corona was so much hotter, they would look at the near-sun environment, the electrons, the ions, the magnetic fields, and the plasma waves, right? And how all of those transport and dissipate energy in the solar atmosphere. So that's what previous research focused on, those things. The dust was long assumed to be largely irrelevant so close to the sun. I think a lot of them thought that the dust didn't even survive the close environment to the sun, so it was kind of irrelevant. And that was until the Parker Solar Probe, which I think we've discussed this on the show. It's been a while. This was launched in 2018. It was the first spacecraft to fly into the low solar corona of the sun. And it's kind of funny because the Parker Solar Probe does not have a dedicated dust collector. So how the hell does it even know about dust? Well, it turns out that the tiny charged dust grains in that environment in the lower corona hit the spacecraft. And when those dust particles hit the spacecraft, they vaporized into plasma clouds, and that produced a sharp voltage spikes on the antennas. So in a sense, the entire Parker Solar Probe was acting as a dust collector, and that's how they found out that dust existed. So that was the big surprise. The dust grains not only survived that close to the sun, but the even more interesting part of that is that it appears to interact with the plasma. And this is what really sets this study apart from all the others. It adds to the typical models the possible interactions with these charged dust grains. No other major studies really incorporated dust grains in their models because it was thought basically universally that they were, irrelevant or not even a player because they weren't even there. Lead author Syed Ayaz says, this matters for solar physics because charged dust grains are not just passive particles. Once dust grains acquire an electric charge, they interact with electric and magnetic fields, they influence plasma waves, and modify how energy is transported and dissipated. So these charged dust grains could have a critical impact onto the exact reason why the solar corona, has such a high temperature compared to the photosphere of the sun. As they explore this in the future and get a better handle on it, it could turn out to be basically the ultimate reason why there's such a temperature disparity. IAZ envisions a future emissions using dedicated dust and plasma instruments. And yes, this could give a much more definitive answer to this coronal mystery. Ayaz concludes, the bigger question is fascinating. Is dust simply passing through the near-sun environment, or is it helping shape how electromagnetic energy becomes heat and solar wind motion? So my takeaway that I'd like to end with is that this is not academic, right? This isn't just, oh, isn't that interesting? This little mystery is solved. There's a much larger implication. The dust in this plasma may not be just passive debris as we thought. It could become an important part of plasma physics itself. This could matter anywhere in the solar system or the universe where dust and plasma coexist, around stars, planets, moons, comets, spacecraft, even industrial plasma reactors. It could potentially impact future moon or asteroid missions, right? It could help predict how fine dust moves, how this dust sticks to equipment and interferes with instruments. That would be critical information in many scenarios. It could improve our understanding of space weather. I mean, that could actually save lives potentially. And closer to Earth, this isn't all just taking place, well beyond the Earth. On the Earth itself, this kind of information could help with semiconductor manufacturing and plasma etching. And the one that I was interested in here is that this charged dust may help us understand and control this. This boundary layer of fusion plasmas. Like if you have a tokamak, you've got plasma, but that plasma is within a magnetic field, but it's also within these walls, and it's really damaging to the walls, and it actually creates this dirty plasma. Now, in this scenario, this would be an impurity. You do not want this type of dust within your tokamak reactor, because that's not going to, having the dust there is not going to make it hotter like it might do in the solar corona. But this information could help us deal with that and control this type of the bad plasma dust, if you will. So interesting paper. Check out some of the treatments on this online. It's fascinating.
All right. Thanks, Bob. Kara, you're going to do your first quickie. What do you got to tell us?
Whoa.
Oh, gosh. So much pressure. Bob,
roll
don't
with
listen
it.
too
You're
closely,
fine.
Okay? It's not going to be pithy like yours, but hey, gird your loins, Bob.
Oh, my goodness. All right. I deserve that totally. Thank you.
You did.
They're girded.
So, did you know that inside of the walls of the damaged nuclear reactor in Chernobyl, there are all sorts of life forms that are thriving? Now, part of that is because human beings are no longer there. And so without our messy hands getting in the way of things, a lot of things are just like, enjoying life. But another part of that has to do with ionizing radiation. So there's a really interesting organism. It's actually a fungus, I think a black mold. It's called Cladosporium sphaerospermum. And a lot of scientists think that the pigment inside of this mold, the melanin that it possesses, is actually allowing it to utilize a process. It's really a theoretical process right now called radiosynthesis. They do think it's happening, but they don't know how. And the idea is that it's similar to photosynthesis, but instead of utilizing light, they're utilizing that ionizing radiation.
Woof.
I know, because ionizing radiation usually kills things, right? It usually is not good for life. But interestingly, within the exclusion zone, scientists recognized as far back as the 1990s that there was this interesting fungus. And they actually found 37 different species of fungus. And a lot of them tended to be really, really dark and full of melanin. But they were dominated by this one specific species. And the more that we dig into it, the more interesting things that we learn. It continues to thrive and overwhelm in the presence of ionizing radiation. They even did an experiment. You're going to love this, Bob. A paper that was published in 2022 where they took this mold into space, slapped it on the outside of the ISS, and exposed it to cosmic radiation. It did great.
Wow.
Wow. So cosmic and probably also solar radiation was a factor too, probably both.
Yeah, who knows? And so they didn't, they still don't understand whether radiosynthesis is a real thing. They still don't understand how in the hell that it would work. But they do know that when you expose this fungus to radiation, it just lives and lives and it loves it.
It's like the ghouls from Fallout.
Yeah. And so scientists are thinking, hey, what if we coat our spaceships with this? Could this be something that reduces the amount of radiation getting in or just something that continues to thrive that we can utilize as a food source? Who knows?
Yeah, who knows?
There's so many possibilities.
How
here.
cool is that?
On the inside of the capsules.
That's so crazy.
So, Kara, do they think that this was just kind of a normal fungus that then got irradiated and mutated?
Sure.
Or has it existed for longer than we know and it just kind of thrived so much in this
there are
environment?
classes of melanated fungus, right? Of deeply melanated fungus. And so it could be that there was something in it already and also it, got mutated to
it's ionizing
no
after
end.
all.
Yeah.
Oh, how cool is that? It's funny. You take a microscope and you look down, you see little hulks down there like feeding off the radiation. Thank you.
All right. Good job, Kara.
Yeah.
Thank you.
Nice.
I did it.
All right, Jay, it's Who's That Noisy time.
All right, guys. Last week I played This Noisy.
Straight up. Gorgeous.
Wow. Okay, so did you guys guess? Did you have any ideas?
Yeah, some cute baby bird.
Bob?
I feel like it's some sort of experimental something because there's somebody in the background looking at it going, gorgeous.
Oh, I didn't hear that.
Okay, well, Kelly Eckersley wrote in and said, hey, Jay, is this a gyro ball? Tell Bob they're great for improving forearms and grip strength. So
yeah.
Gyro ball is it's a thing you hold in your hands, but let's say it's the size of like a tennis ball, and you pull. It's like it has a gyroscope in it, right? But it's a heavy duty one, and then when you rotate your wrist as you're holding it, it gives you significant resistance. So you can actually exercise your wrist with one of those. It's not a gyro ball. I thought that was a really good guess. Another listener named Joe Ian Andrea wrote in, and he said, I'm guessing this week's Noisy is some sort of hand-cranked centrifuge, specifically one of those salad spinners used to spin dry lettuce leaves after washing. I thought his guess was very funny because the guy says in there, what did he say? It's going to be fantastic. In the beginning of that, you hear the voice in there?
I hear him go, gorgeous.
Or gorgeous. Yeah, I'm sorry, gorgeous.
Yeah.
Yeah, so that's a fun response to somebody spinning up some lettuce. Anyway, that's not correct, but thanks you for the guess. Another listener named Lacey Hageman wrote in and said this sounds like a diamond drill or core drilling where water is used to keep the bit from overheating. Now, I've heard that sound, and this was a very good guess because there are some elements of that sound here. So I thought you did a good job on that, but Lacey, you're not correct. And I have another guess. This is from a listener named Kathy Taylor. And Kathy said, the Noisy made me think of a fishing reel spinning out with a big fish on the line. Can't be deep sea fishing because I don't hear ocean waves, but I'm guessing they caught a gorgeous fish. So that is not correct, but many people wrote that one in. So I guess there was something to that. There was no winner, guys.
Oh.
This is an ice screw for climbing. Right? So there are people who climb sheer ice faces, widely known as an incredibly dangerous sport. They have two sickle-shaped tools in their hands. It's like, imagine like a big hammer, but it's just the teeth part and it's really long. They use those to climb. Now they can put this screw in. The cool thing about this screw, it's a hollow screw. So imagine this thing is about 10 inches long and maybe maybe an inch across. And it screws into the ice, but the center of it, the ice that's being cut away is actually falling out of the center of the screw, so you can screw it right in without a problem.
Oh,
so let me play it for you again. I won't play the whole thing because you don't need to hear it all again, but this will give you the idea.
Gorgeous.
You get it?
Is it manual or electric?
This one is manual. I don't know if there are electric versions, Bob. There might be. I've never seen it.
So you need two hands to screw the skin in as you're climbing?
No, I think they just put it on the face of the ice, and the guy just starts turning it because the end of it has like a little like ratchet handle.
Oh,
You know what I
okay.
mean?
Yeah,
So
yeah.
what's
And
it
as soon as
called?
it catches, it just goes, and seemingly without any resistance. It looked like an easy thing to do.
Yeah, and then you use that to go up a certain amount, right? And then you do another one?
Yeah, it could also be used for a safety hook. I think, like you climb up and you can, you
Right.
hook yourself
right.
to
Yeah.
it, and then you disconnect and keep
If you
going.
fall, you're not like dead.
Guys, I have a new noisy this week. It was sent in by a listener named Jody Lesko, and here it is. Guys, this one can sound pretty annoying or painful, so lower your volume a little bit, but I assure you that the end result of this one will be fun.
It's like a sonic weapon, man.
All right, guys, we've done so many shows this year already, but we have the big one coming up. This is a 2-week jaunt to Australia and New Zealand. I think you already know what I'm about to say, but we're going to be doing a first stop in LA, right? I always forget LA, Kara.
How dare you?
Well, it's because it's in our country and it's not like it's not the big move.
It's pretty big. I'm excited.
All right, so in LA, we're going to be doing a super secret meetup on Friday, the 17th. And then the next day, we're doing something called SGU Live and Beyond, because it goes beyond a live SGU podcast, because there is 4 hours of content. It's a live podcast recording, and then we're going to be doing 2 hours of fun and entertainment. Don't forget that George, Andrea, and Brian will be joining the SGU crew. So it's going to be a lot of fun. If you're interested, go to theskepticsguide.org and click the events button, and you'll see ticket and information on the events page. Then we're going to be in Australia. We will be doing our Nauticon conference in Australia. It's called Nauticon 2026, Life, the Universe, and Everything. This is going to be a incredibly fun conference. If you've never been to one, it's a socializing conference. You're going to meet people. You're going to make friends. There's going to be a lot of audience interaction with the things that we'll be doing on stage. There will be an extravaganza, and there'll be live podcast recording, and there'll be a board game event, and there's VIP, and there's all sorts of cool stuff. So please join us. Go to theskepticsguide.org or go to nauticoncon.com. And then for our New Zealand friends, right? Is it ZZ? So it's New
Yes.
Zealand. Hey, it's legit. They pronounce the letter Z differently. Which isn't it weird? Like they think we're weird, we think they're weird, but we all love each other. It's a fine relationship we have. So you could go to conference.skeptics.nz to find out all the details about our conference there. So at the New Zealand conference on Friday, the 31st of July, we will be doing a live extravaganza show in the afternoon, and then that night we will be attending the dinner, and then on Saturday, August 1st, we will be running all the content for the conference that day. There'll be live talks, and there'll be probably panel discussions and some fun content for you guys, plus an SGU live recording. You can go to conference.skeptics.nz.
All right, guys. I just wanted to just generally go over all the feedback we've been getting on Evan leaving the show. And, I've tried to read as much of it as I can, both emails, Reddit, Patreon, Discord, all of it. I think the good thing is that the vast majority of the feedback has been very supportive, thoughtful, kind, and we really, really appreciate that. That's sort of the two standard deviations I like to think about in response. There have been a number of responses all along the same lines that I wanted to address, because a few people, and it's interesting because all of them, they said something along the lines of, I haven't read what Evan actually wrote, but, and then they, were critical of the way that we handle it, basically interpreting it as us censoring Evan for his political opinions, even though we said explicitly that's not what we're doing. So in each case, I basically said, well, you can't really understand why we did what we did without knowing what he wrote. And then I gave some examples, which I think most people of those people said, oh, now I understand, basically. So I just wanted to basically do that here. So again, the reason Evan decided to resign from the SGU is that I think he understood why what he did was wrong. So just to recap here, Evan created an account on X branded with the SGU, right? Evan SGU. He did that without informing me, without my permission, without any discussion about what would be appropriate or inappropriate. He just did it on his own. And then under the SGU brand, he started to make a lot of tweets that were divisive. Some people would say are hateful, were insulting. Provocative is sort of, I think, the most charitable way to say it. Essentially breaking our policy, right? Doing the exact kind of communication that is anathema to scientific skepticism, to thoughtful discussion. And again, it's not as if he was expressing nuanced, thoughtful political opinions that we disagreed with. It wasn't about that. These were just cheesy tweets that were unnecessarily provocative and insulting.
Yeah, I mean, I think, and we're not going to sit here, obviously, and read these tweets out loud. You can go online and look at these things. But I just to be explicit, like he was advocating for war crimes online.
Yeah, exactly.
Like they were intense tweets.
Yeah.
I think people listening who haven't looked and are like, man, you guys really canceled him, or you guys no, he did this. It was brought to our attention. We were deeply disappointed. He was deeply apologetic, and he chose to resign.
Yeah. No, again,
that is what happened.
The thing that got him to that point, based on my discussion with him, was he understood that, this kind of communication is incompatible with the kind of communication we do on the SGU. You can't do both.
Yes.
And he's like, I don't know what I was thinking. I just can't continue. And I agree. This is why these are the rules. This is why you should have talked to me about it before you decided to do that. I mean, obviously we have to address the opinions themselves. I'm not saying that's not the issue. It is the issue. But, he essentially put us in an absolutely no-win scenario. And the critical emails are actually evidence of that. He created a situation where no matter what we did or didn't do or said or didn't say, we were going to piss off a huge chunk of our listeners, right? That's the reason why you don't communicate like that. If we're, unless that's what you want to be, you got to be one or the other. You can't be both. You can't be a skeptical science communicator and a political provocateur on X. You can't be both of those things at the same time.
That's the part that I've found myself being so frustrated by. I don't know if, Steve, this has been your experience, but the people who are basically like, you didn't go far enough, and then in the same breath, other people saying you went too far.
Exactly. That's the two standard deviations I'm talking about. I think most people are like, you guys did as good as you could do given the situation. But then on one side, where the people like you didn't go far enough. On the other side, people we went too far. And it's like, there's no point. There's nothing we could have done to have prevented that kind of response, that range of response. It only could be worse, I think.
I agree.
Right.
And we also cannot control another human being.
Yeah.
And I think that's an important point here. I feel like there are a lot of fingers being pointed saying, why did you let? How could you have allowed? Why didn't you stop? He is a human being with his own voice. And he chose to use his voice. All we can do is choose boundaries around that.
I think he somehow convinced himself he could isolate that from his work on the SGU.
I think so too. And clearly he couldn't. But I think the onus that people are putting on us to have somehow been in his head when he was choosing to prevent us access to those thoughts. Like, intentionally preventing it. How could you be friends with somebody for so long without? That's why I said last week, don't have the hubris to think you know who everyone in your life is or what they are like behind closed doors.
And people can be multiple things at the same time. Listen, Evan is still our friend. He's been my friend for over 30 years. He and his wife babysat my kids. I'm still reaching out to him. I still love the guy. I want to work through this every way I can. I'm feeling for him. I know he's hurting a lot right now.
Absolutely.
And
I invited him to my birthday party. I mean,
of course.
We are still absolutely friends.
But he also has this part of him that we didn't know about that was really dark, and we're trying to deal with that as best we can.
And at the very least, it should not be a voice on the SGU.
But that's a separate issue from what's appropriate on the SGU. Absolutely.
Yeah. And to be clear, he resigned. Yeah. I think that's a point that bears repeating. I think there's a lot of weird speech online that I've had my attention drawn to of oh yeah, he quote resigned. Like, no, he resigned.
Yeah.
Like, don't question that.
Yeah,
This
but
is not a
guys, also
conspiracy.
should we address the point that they make is that but you gave him no choice but to resign.
That's not
Do you
true.
Want to address?
And it's
I know,
not
but
true.
I know,
That's
but
literally not true. Our choice, the choice we gave him was, you have to work through this with us, and we were doing that. It's like, you're going to take a break from the show while we wrap our head around this and while we talk about what all this means and how we could move forward. And we were in that process, and he just, I think, got overwhelmed by everything. And, he also said to me, more is going to come out. Like this is not done.
Okay.
And he didn't want there to be this steady drip of, controversy. Like, he did what a lot of people do in a situation like this. You take a hit for the team and you resign when you created a mess that is now going to be a huge problem for other people. So, and the truth is, we didn't come to a conclusion. It was open-ended. Evan knew he may never come back to the show. He knew that there was a lot of work ahead if he ever were going to come back to the show. It was an open question. It was a process. We don't make snap decisions about something so complicated. And then he said, okay, well, we could short circuit this process because I'm resigning. And, we talked last week about why I think that actually simplifies things for him and for us and for the whole,
And for us,
the whole process.
But I think it's also bears saying, and maybe you agree, maybe you don't, like, there's no universe in which there's not a path
To
for
redemption.
him to come back. Yeah.
Totally.
But we can't do that work for him.
Right.
So, we're here.
I think for me, the friendship is 100% in play. I'm not, I love Evan, and I'm not going to abandon him because of something like this. Like, if anything, he needs us. He needs his friends. He needs people around him that have rational voices and everything. In regards to him being on the SGU, though, I mean, that is a different animal, because we do have an editorial policy, and there's a lot that we all sacrifice to do this show, right? There's just a lot of things that we've all agreed to, and things that we, behaviors and things that we have, because it's the appropriate way to be when you have a show like this. We have a lot of things that are unspoken on the show that are spoken between us of, this is the kind of show we want, this is the messaging that we want to push out. And Evan broke out of that, and he knows it. Everybody that listens to the show knows it for the most part. And I just find it very important to note that there's a very big difference between us managing the show and us managing our friendship with Evan.
Yeah, absolutely. But I have very little tolerance for people who just straight up say, oh, you're lying, I don't believe you. It's like, really?
I know, me too.
I mean, come on, we're being so honest
insulting.
and transparent here. Plus, people confuse cynicism with skepticism. It's like, you're not clever just because you're being cynical. That's cheap. Anybody can do that. Right? You don't know what's going on. You don't, it's a complicated situation. You have no secret insight or window into it. We're telling you as transparently as we can what's happened. And, whatever, you choose not to believe us, good, fine.
Yeah. I just have long struggled with the tendency that a lot of people have. And, I think the internet is just like not the healthiest place for this, but the tendency that a lot of people have to pass judgment or criticize without in the same breath saying this would have been a different approach, or this would be I don't want criticism. I want constructive criticism in my life. Right. You know what I mean? Like, it's not helpful to be like, that's horrible and everything you did was wrong and screw you. I'm never listening. Okay, I'm sorry. I hate that if we lose a listener over this, I hate that. But also, it's like, I think we were put in a really tough situation. This was really hard for all of us. We did what we could. I think a lot of people online have reinforced that, we handled it as best we could. But it's not helpful to tell us that everything is wrong and there's no path to betterment.
Yeah, I know. Like the emails of not, oh, have you considered doing this? But just, I'm out. I didn't like that. I'm out. It's like, okay, well.
Okay, yeah. Sure. Like that's your choice. That's how boundaries work, right? Like we can only set boundaries for ourselves. That's the way the world works.
But it is, and sometimes it's also a profound lack of humility, which again, I think was the part of the Evans problem, was a lack of humility, where people think that they can know what's going on from whatever limited perspective they have. I mean, people were casting judgment without even reading any of his tweets.
Yeah, I think there was an assumption that they just couldn't be that bad, right? Yeah, and it's like, no, but they were.
Yeah, and look, it's interesting this whole thing is such an interesting situation, like just analyzing it and being on the receiving end of all this communication from all these different people around the world in response to this, and our responses as well, right? Because, we would like to think that we're all going to like behave in a particular way that's the most rational and the most critical, all that stuff. But bottom line is our emotions are heavily engaged in this, and emotion can typically trump higher levels of thinking, right? And that's why we wanted to take our time and not rush our decisions and everything, because the first few days, the way it felt to us over those first 3 to 4 days, say, are very different than 2.5 weeks out.
Yeah, absolutely. Yeah.
And also, like, I think a lot of responses we got were very knee jerky by a lot of people, and we get that, But look, we are all fallible too. There has been a lot of responses that we got that, I would say like weren't really practicing critical thinking and skepticism as well. Again, because of the emotion, and it's all okay.
It is. Yeah. To that end, we also got a lot of responses that were very thoughtful.
I do want to emphasize most responses were awesome. People were being very critical thinking, very supportive, very thoughtful,
and generous.
And generous.
We really appreciated that.
Yeah, that is the 95%er. I do want to emphasize that.
Yeah.
All right, guys, let's move on. It's time for science or fiction.
It's time for science or fiction.
Each week, I come up with 3 science news items or facts, 2 genuine and 1 fictitious, and then I challenge my panel of skeptics to tell me which one is the fake. There's a theme, and the theme is, what's it in 2 days? When this show airs, it's going to be what day?
Today's the 2nd.
4th of July.
4th of July. It's Bob's birthday. Happy birthday, Bob.
Thank you.
So to celebrate the 4th of July and the America's 250th anniversary, I have a American history themed science or fiction. Are you guys ready?
I'm with you.
All right, here we go. Item number 1. George Washington, while a lieutenant colonel in the Virginia militia, committed an epic blunder which was responsible for starting the French and Indian War. All right, number 2. During part of the Revolutionary War, Abigail Adams was a spy for the Continental Congress, engaging in espionage to gather intelligence and plant misinformation. And item number 3. Thomas Jefferson popularized macaroni and cheese in America and even designed his own pasta-making machine. Bob, you go first.
I thought this would seem hard, but it doesn't seem hard to me. So for the second one, Abigail Adams, spy for the Continental Congress. I love this. I want to learn more about it, and I hope it's true. And it's kind of weirdly ringing a bell, but, my memory's basically untrustworthy once you go back a bunch of years. It's like who knows what bells are ringing, but that kind of makes sense. The third one here, the macaroni and cheese one, I'm totally buying that from Thomas Jefferson. The only one that I had a really negative gut reaction to was George Washington essentially starting the French and Indian War. I think we would all know this. I mean, and that's, of course, a classic blunder that we have made many times on this segment of the show, and I could be wrong again, but that just seems something that, did not happen. So, epic blunder by Washington, fiction.
All right, Jay?
Wow, that was, Bob, you went right to it, man.
He did, yeah.
Okay, so the first one, George Washington, he while he was a lieutenant colonel in the Virginia militia, he committed an epic blunder, which was starting the French and Indian War. I mean, how can that possibly be true? Right?
That's what
if I didn't hear that, like, is this a complete failure of every history I've ever read? I don't know. That one seems very likely the fiction to me. Then during part of the Revolutionary War, Abigail Adams was a spy for the Continental Congress. Wow, that's cool. I agree with Bob. I hope that's true. Very cool. And of course, Thomas Jefferson. I mean, my God, if anybody is going to popularize macaroni and cheese and even design his own pasta making machine,
Right?
It's got to be him. So that to me, like, I'm just going to write out and say that's science. The first one seems so unbelievably off. I just can't believe it. You know what? That's got to be the fiction. George Washington did not start a war. Goodbye.
Okay, and Kara?
I disagree.
Oh, God damn it.
I don't know about the macaroni thing. That
and
one
they
is
called
like,
it macaroni.
I know, I was thinking that too, but then I was like, there is no way those two things are related. And they called it macaroni and cheese in his hat. So I don't know, maybe Thomas Jefferson did popularize macaroni and cheese. I mean, I know a lot of these guys traveled a lot to Europe.
Yeah.
Maybe he discovered this, while he was in his travels and brought it back. So sure, that one's science. But for me, between George Washington being, a young military leader in a Virginia militia, which means that at the time, was he fighting for the British? I mean, this was prior.
Yeah.
So, right, in the French and Indian War, which is French, these were the places that were in dispute. And he was probably part of these battles. I mean, ultimately, didn't we choose him to be the first president because of his military history in America and because of his ability to kind of stand up on the, quote, patriot side? But prior to that, it was pretty complicated where the allegiances were. So I don't know. That doesn't bother me the way that it seems to. Something had to start the war.
Don't you think his opponent, when he was running for president, say, and you want to vote for this guy who started this war? I mean, wouldn't that be the killer?
Because he also was responsible for America becoming independent, right? There probably were more focusing on that at the time. So I don't know. That one doesn't bother me.
Putting spin on it.
Yeah, but I feel like I don't know. Like I watched that whole series about John Adams, Paul Giamatti, and like I loved Abigail Adams' role. It was
Giamatti,
who played
I love
her.
him.
Oh, Laura? No, it wasn't Laura Linney. I can't remember who played her, but I loved that series.
I don't
remember
see
her
that
ever being
series.
a spy in it. That one's bananas to me. I don't think that the second first lady of the very, very young United States was spying and engaging in actual espionage and planting misinformation.
Ooh, I mean, she was to be true.
Yeah, she was probably like, really, well, not probably, I think she was really guiding her husband and offering a lot of support and advice at the time, like many of these women did. But I don't think she was a spy. I'm going to say that's the fiction.
Wait, can I say something in response to Kara now that she made her choice?
Yes.
Spies don't necessarily have to be doing backflips away from atomic explosions and things like that. Like they could pass a note. They can do like minor things too that are still cool, but not like overt or impossible.
Yeah, but this says she was engaging in espionage.
Yeah, but that literally could be like spilling coffee on a document.
It could if it results in those charges.
Well, we can only wait and see, Kara.
All right. Well, you all agree on the third one, so we'll start there. Thomas Jefferson popularized macaroni and cheese in America and even designed his own pasta making machine. You guys all think this one is science, and this one is science. This is science. Yeah, these guys were doing all kinds of things, and Jefferson did travel in Europe a lot. He learned how to make macaroni and cheese in France, although he didn't learn how to make it. His slave chef did.
Of course.
Yeah, so while he was there, his enslaved chef got trained by French cooks, and learned how to make macaroni and cheese. Jefferson did then, he didn't, no one thinks that he quote unquote invented it. He just brought it back to the U.S. He did have his own sort of version of it. Again, he did write a recipe for it, but it was probably dictated to him by his chef.
Yeah.
And he did make it. There's a drawing of a pasta making machine that he invented in the Library of Congress.
So if he hadn't brought it back, someone would have, because mac and cheese is just too good.
Right?
Yeah.
But this was like high cuisine for the elite of the American colonies and in America at the time.
Well, that was like when chocolate first came around. Like it was like an upper class drink.
Yeah. Mac and cheese. All right. Let's go to number 2. During part of the Revolutionary War, Abigail Adams was a spy for the Continental Congress, engaging in espionage to gather intelligence and plant misinformation. Kara, you think this is the fiction. The boys think this one is science. And this one is the fiction. This is the fiction.
Wow.
But Abigail Adams was awesome. Now, sometimes people have referred to her as a spy or includes her in the list of female spies during the Revolutionary War, but she never actually did anything that can be considered espionage and never planted misinformation. What she basically did is when she was living in Boston and the Continental Congress was in Philadelphia. She was sending letters to John Adams and basically telling him all public information if you were somebody living in Boston. But remember that there was no telephones, no telegrams, whatever. So she was a major source of tactical information to the Continental Congress, telling them everything that was going on in Boston, including troop movements and whatnot. So it was
sounds like a spy to me.
It was military.
Not if you could see it. Not if anybody could see it with their own eyes.
Right. It was all publicly available information. She never committed any actual espionage and never planted misinformation. But she was a very important source of tactical information for the Continental Congress. She also did a lot of other awesome things. She was a badass. So when her husband John Adams was busy doing stuff, it was up to her to run the business, the family business. And now at the time, women couldn't own property; they couldn't do anything. Right? It was their husbands owned everything, but he just basically signed off on whatever she wanted to do, and she made bank. He basically said, invest in the farm and farming. And she's like, nope, I'm not going to do that.
I'm going to invest in cryptocurrency.
Well, the equivalent of cryptocurrency at the time, Bob, what she did was buy up a whole bunch of really depreciated war bonds.
Hell yeah.
Because if they lost, these would be worthless at the end of the Revolutionary War. So she was basically betting on the Revolutionary War winning the war. And when she did, she was basically made the Adams fabulously wealthy. So she was much better at financial investments than her husband. She was just better at running the household. She actually managed to get her whole family inoculated against smallpox, which was a feat at the time.
Wow.
Mm-hmm.
Yeah, so she was an absolute badass. All right. I didn't want to take away from her from being the fiction, but that's why I wanted to make sure I mentioned all that stuff, which means that George Washington, while lieutenant colonel in the Virginia militia, committed an epic blunder which was responsible for starting the French and Indian War. Is science. This is true. And right? You think Washington started the French and Indian War? Him?
Why would they bury that lead?
It's amazing, right?
Because he made up for it later.
Washington, so the Virginia militia, they were fighting for the British. He wasn't a British officer. He was a Virginia militia officer, but the militias were operating under British commanders, right? We were still, at the time, we were loyal to the British. This is before all the problems. And the Ohio territories were disputed between the French and the British. And Washington was sent with his group to basically send a notice to the French saying these are our demands. And at the same time, the French sent an emissary, basically a diplomat, to the British to try to work it out so they could peacefully resolve their differences. Washington comes across his group, and the American Indian scouts that he was with convinced him that they were hostile, and he attacked them, killing the diplomat. And so then the French were pissed off because they basically ambushed and killed their emissary, so they launched a counterattack against Washington's unit. He had to retreat. He then built a makeshift fort called Fort Necessity in a terrible area that couldn't be defended. It was a complete piece of crap, and he gets the shit kicked out of him, and he has to surrender to the French.
Let's vote for him for president.
Good thing he lived.
Oh,
he did some really good stuff after that.
He may not have survived. And then it's worse because so he didn't speak French. The French delivered their terms for peace. And the only translator Washington had access to was a Dutch person who spoke a little English and a little French. And so he sort of translated the document for Washington, who signed it, not realizing he claimed to his dying day, not realizing that the document said that Washington was guilty of murder and accepted full responsibility for killing their emissary. And when that document got to London and Paris, it started the French and Indian War.
Holy crap, man.
Washington resigns in disgrace, basically.
Oh my God.
So his goal was always to become a British officer, and that was done.
Are you British?
So what's the takeaway, Kara?
Pay attention in your foreign language classes this week.
Now, my takeaway is this. I may need to watch more historical documentaries and not so much about quarks and quantum fields, but I don't think I'm going to do that.
I am burning my way through a whole bunch of American history documentaries. Washington and Jefferson.
Oh, are those the new
and
ones that
Grant
are on...
and Lincoln and Teddy Roosevelt. They are all awesome. I highly
Aren't there some new ones on Netflix? Is that what you're watching?
Yeah, over the last 3 or 4 years, these have all been coming out. They're all really, really good. Teddy Roosevelt, also huge badass. I underappreciated how great a president he was.
He had some
cool.
he had some shortcomings too.
They
But yes,
all do.
agree.
They are all complicated with lots of shortcomings, but he was incredibly progressive for his time. He had a lot right. His biggest mistake, honestly, was not running for a third term.
Ooh.
He trusted Taft. It turned out to be a disaster. Anyway, I highly recommend those historical documentaries. Basically, that's my patriotic thing to do. I'm going to watch all these American history documentaries, and you learn so much. I was surprised that Washington started the French and Indian War, because I don't remember that from my history class.
Yeah.
But how much do you really remember about the French and Indian War?
Well, everything I remember about it, I learned from The Last of the Mohicans.
There you go.
I'm right, Steve. You read my mind. I'm right there with you. That movie's been going through my mind the past 4.5 minutes.
Great movie. Still one of my favorite
Oh my
movies.
God. I will find you.
All right, Bob, give us a quote.
All right, I refuse. I'm going to give you I'm going to give you 4 quotes. So how about that? So a little bit of twist here. So this first quote is from mathematician Benoit Mandelbrot, who made one of the most famous fractals of Mandelbrot said. He said, asking the right questions is as important as answering them. But that sentiment, which I love this sentiment sentiment's not unique. You have writer and philosopher Voltaire said, judge a man by his questions rather than by his answers. Then you've got anthropologist and ethnologist Claude Levi-Strauss, who said, the scientist is not a person who gives the right answers. They are the ones who ask the right questions. And I will end on Einstein's, maybe this is the best one of the bunch. Maybe I should have led with this. Oh, well. Einstein said, and I had never heard this before, if I had an hour to solve a problem and my life depended on the solution, I would spend the first 55 minutes determining the proper question to ask. For once I know the proper question, I could solve the problem in less than 5 minutes, which is such a great variation on that whole sentiment that these people we're trying to get across here. And I think this absolutely ties into scientific skepticism, which we were discussing earlier. In a sense, not caring about the answer, not having an emotional investment where the facts lead, but asking the right questions will absolutely get you to your goal faster. And the other connection this brings to mind is what we refer to as Google foo. When you're just trying to Google around, trying to get an answer to a question, sometimes you just need to Google first what the right question is before you're going to find what you're looking for. So knowing the right question is often the most important part of that whole process.
And Bob, I will go even farther than that.
Keep going. Do it.
Scientists, I think, will look at this and say, yeah, this is like where all the genius of and all the work of science is mentally is in figuring out the right question. That's everything. Once you have the right question, then it's just a matter of doing the research and answering it. But the hard work, the real brilliant scientists are the ones who can figure out the right question to ask.
Right.
It's so important. It's so much more important. And then
And
the answering it is the technical part,
Right. And perhaps a corollary to that would be some of the best scientific discoveries are ones that not definitively answer something, but that raise their own whole set of questions after that. Those are the kind of discoveries that scientists really love.
And pseudoscientists often ask the wrong question.
Yeah.
Right? And that's part of their problem. All right. Well, thank you all for joining me this week.
You're welcome, Steve.
Sure, man.
And
Thanks, Steve.
until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.